We are on Unit 4. This is the first section, so this is Notes 1 of Unit 4, and in this section we are going to be working on a concept called optimization. In Unit 3 we analyzed functions, maxes, mins, points of inflection, lots of things like that. In this unit we will apply what we learned in Unit 3 to situations. Sometimes we might be asked to maximize profits or minimize costs. In optimization, we're finding the maximum or the minimum of something. Okay? So let's say, for instance, that we have a situation. We write the equation describing what we're trying to maximize or minimize. Okay? And the graph of that equation, maybe it looks like that, okay? If that's our equation, let's say that this is our profit equation. So that would be the equation describing the profits. If we wanted to maximize our profits, then we would need to find the x value that makes that point, right? If we were able to find that x value, we would be able to maximize the profits. Well, what's happening at that x value? At that x value, the derivative of profit is 0, right? So if we set the derivative equal to 0, solve it for x, we would be able to find the x value that creates the most profit. Okay? You could have similar situation describing costs, volume, area, lots of different situations that we can maximize or minimize in. But that's in general going to be our process. Find the equation, take the derivative, set it equal to 0, and then answer the question that's being asked. In general, that's the steps. Now, I have some really drawn out steps here, okay? Because some of you are like, no, I need all of the bells and whistles, all of the details. But for those of you who just want to cut to the chase, find the equation, take the derivative, set it equal to 0, solve for xt, whatever your independent variable is. Okay, let's take a look at an example. Find two positive numbers. Find two positive numbers, so we know what we're trying to do. We're finding two positive numbers. I'm going to call those two positive numbers x and y. Okay? Such that the sum of twice the first and 3 times the second is 150. The sum of twice the first and 3 times the second is 150. Comma, there's something more coming. So just right there, it's a sum of twice the first and 3 times the second, and that is 150. And their product is a maximum. Their product is a maximum. How can we write an equation that says the product of these two numbers? So I would call that the product, I would call it capital P for product, is equal to x times y. You always want to make an equation for what you're trying to maximize. That's step 1. Okay, write an equation for what is being maximized or minimized. Okay, so our equation for what is being maximized here is the product. So product equals x times y. Okay. Sometimes you're maximizing volume, so it better say V equals. If you're minimizing area, A equals, things like that. Okay. If you're minimizing cost, maybe C equals. So always write an equation for what you're trying to maximize or minimize. Okay. Next up, we would like to change our equation so that it only has one independent variable, if possible. Sometimes it's not possible, but if it is possible, one independent variable. Right now we have two independent variables, x and y. We would like it to be all x's or all y's. to do this, you will use the other information given to you in the problem. So in this case, we're going to be using 2x, so I'm going to come off to the side, 2x plus 3y is equal to 150. I can solve this for either x or y and plug that expression in for the x or y here, right? And either one is fine. It doesn't matter which one. I think in this case I'm going to solve it for y. So 3y will be 150 minus 2x, and then I'm going to take a third of both sides, right? Multiply both sides by a third, or divide both sides by 3. Y is equal to a third of 150 minus 2/3 x. That expression goes in for y right here. So our new product equation becomes P is equal to x times 50 minus 2/3 x. Okay, now before you dive in and take a derivative, I want to think about this equation, okay? In step 3, analyze that equation. So to analyze this, it may be easiest for you guys to see if you go ahead and distribute the x through. It'll also make it easier for us to take the derivative if we distribute the x through, right? So let's go ahead and distribute that x through. And now I can, not only can I take a derivative easier, but I can see, you guys, what does the graph of this look like? It's a little quadratic, so I know it's a parabola. It has a negative x squared term, so it's a parabola, and it's pointing down. I want for the product to be a maximum, and my product equation looks, the graph of my product equation looks like that. Does it have a maximum? It sure does. It has a maximum right there when p prime equals 0. The slope right there is 0, right? So all I have to do is take the derivative, set it equal to 0. If this equation was different, you guys, if this equation was something that you don't know the graph of, then you're still going to be taking the derivative and set it equal to 0. But then you'll have another step to do after that, okay? Because you're essentially continuing with the closed interval test process. Even if you don't have a closed interval, you're continuing with that process. So you'll still take the derivative, set it equal to 0, but then you'll have another step to do. And we'll do several problems like that, okay? But for now, since we know this one, and a lot of times this does happen, so let's go ahead, take the derivative, set it equal to 0. You don't have to write the word set there. I do that just to let you know what's going on for your notes. Solve this for x. So move the 50 over, and then multiply both sides by the negative 3/4, and x will be 3/4 times 50, which we can simplify a little bit. 2 and 25, right? So this would be 75 halves. Okay? So that was our taking the derivative, set it equal to 0 step. And then our last step is to answer the specific question that's being asked. This is the most often missed part of the problem. Kids get x equals and they just stop. I'm done. I got x. I must be done. We need to, in this case, find the two positive numbers. Sometimes it's find the maximum product, right? So make sure you go back at the end and answer the question that was being asked. So we need to go in now and find y, right? I'm going to come up here and use my y equals equation. So y is equal to 50 minus 2/3 x, which I now know is 75 halves. I can stop there because it is, I should have boxed, anyway. I can stop there and not simplify this. If it's a multiple choice question, which these oftentimes are, but if this is multiple choice, 50 minus 25 is 25. So the multiple choice answer would be 75 halves and 25. Okay? All right, next example. In example 2, it says a ball is thrown straight up from ground level, and I forgot to change this. I need to change that. This is a height of 3 feet. Need to change that. I'm hoping that when you are reading your paper, it already says that. A ball is thrown straight up in the air from a height of 3 feet. Its height after t seconds is given by this equation. What is its maximum height? Sometimes in a problem, they are kind enough to just give us the equation. And this is the case. This is an example of that case. We're trying to maximize height, so I need an equation for height. They gave it to me. So I don't need to go find it because they already gave it to me. Okay? So what is the maximum height? Here's my equation for height. If we look at it quickly, I see an upside down parabola. Again, an upside down parabola. I'm trying to find the maximum of that height. Well, the maximum of the height is right there where s prime is equal to 0, right? The slope right there is 0. So that's what I'm going to do. S prime is equal to negative 32t plus 20. Set that derivative equal to 0, solve it for t. Subtract 20, divide by negative 32, so we'll have 20 over 32. We can reduce that. If it's a multiple choice question, reduce it. If it's not a multiple choice question, don't reduce it. Okay? Now, that was it. So now I'm going to answer the question being asked. What are we being asked? We're asked for what is its maximum height. Is this the maximum height? No, that is the time at which the maximum height occurs. So that's the t value. I want the s value, right? So s at that time is negative 16 times 20 over 32 squared plus 20 times 20 over 32 plus 3. That would be the safe stop answer. And if it was multiple choice, then we would simplify that. Okay? All right, example 3. So I guess I can put this right here, MC answer. Okay? Example 3. At which points on the graph of y is equal to 8 minus x squared are closest to the point 0, 4? This problem is not as straightforward. It's not even straightforward what we're trying to maximize or minimize. What are we trying to maximize or minimize here? Let's take a look at a picture. Well, let's draw our picture, okay? Sometimes it's convenient to draw a picture to make sense of things, okay? So, I'm going to graph our equation, which is a very simple upside down parabola. So let's graph our equation. It is an upside down parabola. When x is 0, y is 8. So here's the vertex of my parabola, and then the coefficient of the x squared is a negative 1. So down 1 over 1, down 4 over 2, right? And so forth. So this would look something like that, right? Just a quick sketch. And that's the graph of that parabola, and we want to know which points on this graph are closest to 0, 4. Where is 0, 4? Well, 0, 4 is right here. So which points on the parabola are closest to that point? It looks to me like they'd be somewhere, maybe right here and here, right? I'm going to label this point XY. So I'm looking for XY and negative XY, right? So still, what am I trying to maximize or minimize here? Well, I want this point because it's closest to this point, so I am minimizing this distance. Whatever this distance is, that's what I'm minimizing, all right? So I'm going to need to pull out of my closet the distance formula. You need to know the distance formula. It comes from the Pythagorean theorem, okay, if that helps. So the distance, I'm going to call the distance capital D, all right? I don't want to use a lowercase d because I don't want it confused with derivative, okay? So whenever I have something that begins with the letter D, like distance, I'm going to call that a capital D instead of lowercase d. So the distance formula is a big square root, comes from the Pythagorean theorem. So it is the sum of the square of the difference of the x's plus the difference of the y's squared, okay? So what is the difference of the x's? X minus 0. What is the difference of the y's? Y minus 4. So there is my distance equation, okay? But it has two independent variables. I would like it to have one if possible. And look what we have. Y is equal to 8 minus x squared. So we could right now put 8 minus x squared in for y, right? We could. Or we could very quickly solve this for x squared and put 8 minus y in place of x squared. Do you see the x squared there? Well, we could put 8 minus y in place of x squared. Either one will work. In one case, you'll be finding the y, and in the other case, you'll be finding the x, but either way will work, okay? Since it's going to give me a lower degree term in here, I'm going to substitute the 8 minus y in for the x squared. But both of those ways will work. So 8 minus y goes in for the x squared, and here I'm going to go ahead and square this binomial, and I will have y squared minus 8y plus 16. Okay, let's clean that up a hair. Underneath that square root, we're going to have y squared minus 9y plus 24. Okay? All right. Do we know what the equation of the distance, do we know what the graph of this distance equation looks like? Probably not offhand, right? It's not like the graph of this height equation that we knew immediately what it looked like. Here's an example where we don't know exactly what this looks like. Okay? It's certainly not a regular parabola, right? Because it's a square root. So this is when where we're going to have to do that extra step at the end. And it's not a bad step, FYI. It's just an extra step. Okay? So we continue and we take, so I'm going to say graph for the sake of your notes, and then question mark, question mark, question mark, because we really are not positive what the graph of that looks like. I'm not. Maybe you are, but I'm not. Okay. So let's take the derivative. Well, we have the derivative of a square root. We're using the chain rule, right? So this will be 1/2 this to the negative 1/2. That will send it to the denominator, right? So 1/2, that's the 1/2, and then the square root of this times the derivative of the inside times the chain rule, right? So the derivative of the inside, 2y minus 9. So that's the derivative of d. We're going to set that equal to 0. Okay. I will say this, a quick analysis of the discriminant in here tells me that this has imaginary coefficients, so it will never be 0. So I can multiply both sides by that, all right? I can multiply both sides by that. So I will be left with 2y minus 9 is equal to 0. Okay? And y will equal positive 9 over 2. I had to get a quick drink. Okay. All right, so now we got that y value. But my question remains, what does that even mean? I know it's where the slope is 0. But is that indeed a minimum of d? Maybe it's a maximum of d. Maybe it's neither, because just because the derivative is 0 doesn't mean we have a max or min, right? So it just means that we have a possible max or min. So if we don't know, we're doing the first derivative test here. Okay? So we are plugging in something to the left, something to the right. And remember that these are y values. This came from a y value, right? It makes sense to me that the y value would have to be between 0 and 8, right? It would have to be between 0 and 8. And it is. It's at 9/2, which is 4.5, right? It kind of visually looks right to me. But visually looks right is not a guarantee that it's the right answer. So let's continue here. Okay. If we put in something from the left, and remember we're putting it in for for d prime, okay? So let's put in maybe a 1. If we put in a 1, we're going to have a negative on top, a positive on the bottom, so the whole thing's going to be negative. If we put in something on the right, we're going to have, maybe if we put in like a 10, 100, something like that. We're going to have a positive over a positive, so it's going to be positive. So the distance equation was decreasing before 9/2, and it is increasing after 9/2. Okay? Therefore, not only is it a relative min here, it is the absolute min, because there's no other place over here where it's going to be, increasing, then decreasing, then it is only decreasing and then only increasing. Okay? So, therefore, we have the minimum, the absolute min, in this case, of d occurs when y equals 9/2. So all we have to do is answer the question, which points on the graph? So we still have to find the x coordinate, right? X squared was equal to 8 minus y. We're going to put 9/2 in for y. So x squared is equal to 8 minus 9/2. X squared is equal to 16 halves minus 9 halves is 7 halves. So x is equal to plus and minus square root of 7 halves. It makes sense that it would be plus or minus, right? So the points on the curve closest to 0, 4 are plus and minus square root 7 halves, 9 halves. And that's our. And by the way, FYI, I said that we didn't know what the graph of this looked like. Let's go ahead and see what it does look like. Okay. What does the graph of that look like? Well, I put it into my calculator. Let's graph it. And if we trace, does it have a minimum? Does the graph of this have a minimum? It sure does. And it happens right here. Right there. And if I zoomed in, or if I found that I can find the minimum using 3, so go from there, enter, 9 halves. Okay, 9 halves. And remember, my x value in my calculator is the y value here. So it's when y is 9 halves. So that makes sense, right? Makes sense. Okay, example 4. A manufacturer wants to design an open box having a an open box. What's an open box? It's a box with no lid, right? And this box has a square base and a surface area of 156 square centimeters. So, and then they ask, what dimensions will produce a box with maximum volume? Sometimes a company might have boxes where they want to restrict the area of the box, but they want to maximize the volume. They want to maximize what can go in, right? So this is a realistic problem. They have restrictions on the area, but they want to maximize the volume. So let's draw a picture of this open box with a square base. So I'm going to draw a little picture of an open box here. Just a quick sketch. When you sketch these, it's just for yourself, you guys. I'm not going to be looking at your picture. Somebody next to you might look at your picture and laugh, but I'm probably not going to laugh. Maybe. If you don't laugh at mine, I won't laugh at yours. Maybe. Okay. This box has a square base. So I'm going to do x and x, right? The height of the box, though, it doesn't have to be x. Maybe it is. I can't restrict it to x. But I know it's going to have a square base. So x and x for the base. And I'm going to put y for my height. If you would rather put an h for the height, fine. I don't care. Whichever, right? Okay, what are we trying to maximize? We're trying to maximize the volume of this box. So I'm going to write my equation for the volume of a box. Well, the volume of a box is length times width times height, right? So x times y, or x squared y. 2 independent variables. I would like it to have 1 independent variable. To get that to be the case, use your other information in the problem. In this case, the surface area is 156. So the surface area of this open box, this is an open box, so this has no lid, right? It's open. The surface area would be the area of the base. The area of the base would be x squared plus the area of this side. The area of this side is xy. The area of this side is also xy. The area of the back is xy. And the area of this side is xy. There are 4 of those, right? But don't include the area of the top because this box, it happens to be open. Okay? So this is the surface area of this box. and it has to be 156. I'm going to take this and solve it for y. Take this and solve it for y. So 4xy is equal to 156 minus x squared. And now I'm going to divide both sides by 4x. Divide both sides by 4x. Okay. I find it easier, you guys. Well, I guess we can leave it like this. That's fine. Now we're going to put this expression of y in for y in our volume equation, right? So volume will equal x squared times 156 minus x squared all over 4x. Let's simplify this. One of the x's here will cancel with this x here. And this 4, I'm going to bring it out front as a 1/4, right? So we're going to have, this is equal to 1/4 x times 156 minus x squared. Now I'm going to distribute. So I have 1/4 of 156. 1/4 of 156, this one, say 39 x minus 1/4 x cubed. Okay, so we've simplified volume. Let's take a quick peek at the graph if we know what the graph looks like. Do we know what the graph of this looks like? Yeah, we kind of do. It's a cubic. I know what a cubic looks like, and it's a negative cubic. So chances are it looks like that. It's either that or it only gets flat, one or the other, right? Okay, I'm looking for the maximum volume. Does this have a maximum? Well, possibly the maximum is right there, or possibly the maximum is somewhere over here. So we're going to need to keep this in mind. Since we're not sure, we're going to need to do a little analysis or a sign chart like we did above after we find our x. Regardless, we take the derivative, set it equal to 0. So v prime is 39 minus 3/4 x. Set it equal to 0. Solve for x. So if we subtract 39 and then multiply both sides by 4/3, we're going to have x is negative 4/3. We're going to have x is equal to 4/3 times 39. 3 goes into 39 13 times. 13 times 4 is 52. So x is equal to 52. And I just realized something. That should be an x squared, right? The derivative should be an x squared there. So that should be an x squared. So this will be x squared is equal to 52. So x is equal to plus and minus the square root of 52. And you might be saying, oh, don't keep that negative, Miss Murray. You can't have a negative dimension of the box. And I'm like, yes, that's very true. However, keep your negative because it's going to help you analyze this graph. What does this mean? This means that right here, x is negative square root of 52. Up here, this must be x is positive square root of 52, right? Which means I don't have to do a sign chart because x can't be negative 52. 0 is between there, right? So the maximum has to be, the maximum volume of this box has to be when x is positive square root of 52. Has to be. That's what I'm talking about, doing analysis, thinking, using your reasoning on these, okay? And if you have to, do a sign chart, okay? But all of this makes sense, okay? Now, we have found the x value. Now we need to find the y value because we're looking for what dimensions. So we need the y value as well. So y is equal to, okay, I'm going to come up here. Y is equal to 156 minus x squared, well, x squared will be 52, over 4 square root of 52. And again, we can simplify this. If it's a multiple choice question, simplify. If it's not a multiple choice question, leave it. Okay? So the dimensions will be square root of 52 by square root of 52. That's x times y, right? And this will be 104. Well, I'm not going to simplify it. Never mind. It begs to be simplified. It kind of hurts not to simplify, but I don't think I'm going to do it. And the dimension, if they asked for units, it would be centimeters. Okay. If they don't ask for units, and they did not ask for units here, my advice is not to give units. Okay. It can only hurt you. Even if they're correct, it won't hurt you. If they're wrong, though, you might lose your answer point for the answer by sticking wrong units on there. That could happen. Okay, I have 2 more examples for you. In example 5, we have a cylindrical metal container. Open at the top. Quick drink here. Okay, and so cylindrical metal container, open at the top, and it is to have a capacity of 54 pi cubic inches. What is capacity? The units here might help you. Capacity is volume. So they're telling us that the volume must be 54 pi cubic inches. Okay? The cost of the material used for the bottom is 50 cents per square inch, and the cost of the material for the curved side is a quarter per square inch. Find the dimensions that will minimize the cost of the material and find the minimum cost. Okay, so we do have a cylinder that is, again, open at the top. They must be putting a special top on. Maybe it's a pull tab top or something like that. Okay. All right. So for right now, though, we're open at the top. So open. All right. What are we trying to maximize, minimize? The cost. We're trying to minimize the cost. So I'm going to let the cost be capital C. All right? And the cost is 50 cents per square inch for the bottom. What would that be? How many square inches are in the bottom? Well, that's the area of the bottom, right? And the bottom is a circle in a cylindrical container, right? So we'll need 50 cents, $0.5 times the area, and that will give us the price of just the bottom. So 50 cents times the area of the bottom. Pi r squared. You need to know that one. I'm not going to give you that. Okay? Plus the cost of the curved side is 25 cents times the area of the curved side. What is the area of the curved side of a cylinder? Remember, if you slice open that cylinder and spread it out, it would be a rectangle. We'd have height of that rectangle, and we would have the length of the rectangle, which would be the circumference of that circle, right? So circumference, you need to know, is 2 pi r, and then the height, then we need to multiply by the height. So the curved side has an area of 2 pi r h. Okay? So that's our equation for the cost of this can. but we have two independent variables, the R and the H. We would like it to have one independent variable. So we're going to use what they gave us for volume here. Okay, the volume has to be 54 pi. So I'm going to come off to the side down here and write my volume equation. Now the volume of a cylinder is one that you would be given, all right? You don't have to memorize that one. But in a volume, in a right circular cylinder or a right box or anything, it's the area of the base times the height. It's the area of the base times the height. So pi r squared h. If this was a cone, it would be a third of that. Okay? FYI. But you'll be given it. And we know that this has to equal 54 pi. So I'm going to take this and solve it for h. H is equal to 54 pi divided by pi r squared. So h is equal to 54 divided by r squared. I'm going to put that in for that h right there. So C is equal to 0.5. You know, I'm going to change this to fractions. I just like fractions better. 1/2 pi r squared, right? Plus, this will be a fourth. A fourth times 2 is 2/4 or 1/2 pi r h, but I'm going to be putting 54 over r squared in for h. Okay, let's clean it up. Whoops, plus, not equals, plus. Half of 54 is 27, right? So 27, the r's will reduce, it's 27 pi, the r's reduce, leaving an r in the bottom. Okay? So this is our simplified cost equation with only one independent variable. Okay? Do you know offhand what the graph of this guy looks like? Me neither. Okay? We could, if we really wanted to spend a lot of time graphing it, but it will that would take more time than it would just to do a little sign chart at the end. So I'm just going to not worry about the graph, do a sign chart at the end after I find r. So, time for a derivative. C prime is equal to, okay, 2 times 1/2 is 1, pi r to the first. So what's the derivative of any constant divided by r? Minus that constant 27 pi over r squared, right? You can think of this as r to the -1, so it would be minus 27 pi r to the -2, right? So it's negative 27 pi over r squared. Set that equal to 0. Okay, let's multiply both sides by r squared. So I'm going to multiply both sides here by r squared. Okay, when I do that, I'm going to get pi r cubed minus, here the r squareds would cancel out, 27 pi is equal to 0. Now we have r cubed, pi r cubed is equal to 27 pi, r cubed is equal to 27, so r is 3. R is 3. So again, my question is, r equals 3 makes the derivative 0. But does that mean that the cost is a max min, or essentially, does that mean that the cost is a minimum there? I don't know. So we need to do a sign chart to make sure it's a minimum. So when r equals 3, I'm doing a sign chart for the derivative because I want the derivative to go from negative to positive. So let's see if it does. Well, if we put a 1 in for 3, if we put a 1 in for 3, put a 1 in for r, if I put a 1 in for r right here, we could put it in right here. If we put a 1 in for R right here, we get a negative, right? If we put a 4 in for R, we get a positive. So yes, the cost went from decreasing to increasing there and only there. Like that other problem, there and only there. So not only is it a relative min, it's also an absolute min. Okay? Yes, it's a min. So we want to find the dimensions. So what are the dimensions of a can? The radius and the height, right? So we want to find the height here, and then we want to find the minimum cost. So the height will be 54 divided by 3 squared, so 6. So the dimensions will be, when the radius is 3 inches, give units if they ask. They didn't ask, so I'm not going to, but it would be inches, and the height is 6. The cost would be, and here the cost would be, I would go into the easiest looking equation for cost that I have, and I think the easiest looking equation is right there. 1/2 pi times 3 squared plus 27 divided by 3. And we can simplify that if we want to, but I think I'm just going to leave it like that. And that would be in dollars. If they asked for the units. Okay? All right. Uno más. One more example. What do you think so far? Same process over and over and over again. Find your equation. Write it with one variable. Clean it up to help you take the derivative. So find the equation, get it in one independent variable, take the derivative, set it equal to 0, solve it. And analyze it. Use your head on these things, you guys. They're going to make sense. So use your head. All right, last one here. An offshore well is located in the ocean at point W, 6 miles from the closest shore point A on a straight shoreline. Okay, let's draw that. We have a straight shoreline, and point A is here, and out in the ocean is the offshore well. I think I'm going to draw it right here, and they call that W. I'm going to call that W for well. And it is 6 miles from the closest shore point. So this must be a right angle here, if it's closest, right? I love it when they have these straight shorelines too. It's so convenient. Okay, all right. So here's our oil well, closest point. All right, the oil is to be piped to a shore point B, that is 8 miles from shore point A. By piping it on a straight line underwater from W to some shore point P between A and B. Then on to B via a pipe along the shoreline. So the pipe is going to come somewhere up through the under the water to P, and then once it gets to P, it'll be along the shoreline the rest of the way to B. Okay? So there's our pipe. Right? Here, a diagram is very nice to see, right? Sometimes it's more important than others. You might be able to visualize a can. It might be more difficult to visualize this situation. Or maybe you can. Okay. If the cost of laying pipe is $100,000 per mile under the water, and $75,000 per mile over land, how far from point A should point P be located to minimize the cost of laying the pipe? A very realistic situation, as realistic as we can do at this point. Okay, I'm sure there would be other factors to consider. All right, so how far should point A from point A should be point P? So this, I'm going to label this X because we're looking for X in this problem, right? Well, if that is X, from A to B is 8 miles. They give us that is 8 miles. So what is just this stretch? Well, that would be 8 minus X. If this is 8 and this is X, then this has to be 8 minus X. This we're also given from A to W is 6. I can use the Pythagorean theorem to get an expression for this hypotenuse. That would be the square root of x squared plus 6 squared. And we want to minimize cost. So let's write the cost equation. Well, the cost equation, I'm going to call it capital C for cost. All right. It's $100,000 per mile underwater. So $100,000 times the distance, the number of miles underwater that the pipe will be laid. Square root of x squared plus 36. Plus $75,000 per mile over land, 8 minus x. Okay? There's our cost equation. How many independent variables do we have? We just have the one. We just have the x. So we're good. Let's take the derivative. Let's go. By the way, do you know what the equation for that, or do you know what the graph of this would look like offhand? No? Okay, well that's fine. We'll just do a quick sign chart at the end then. It's really not a big deal if you don't know what the graph of that looks like. Okay? It just adds the step of a sign chart at the end. Alright, C prime is equal to, I'm going to do, this is a chain rule, so this would be x squared plus 36 to the 1/2. So half of 100,000 is 50,000 times x squared plus 36 to the negative 1/2, right? Times the derivative of the inside, and the derivative of the inside is 2x. So we're back to 100,000. Okay. Plus, okay, over here, if we distributed that 75,000 through, we would have 75,000 times 8. And when you take the derivative of that piece, it's just 0. But then you'd have 75,000 times negative x, and the derivative of that piece is negative 75,000, right? Set equal to 0. Okay? So we have 100,000 x divided by square root x squared plus 36 minus 75,000 is equal to 0. Let's take each side and divide it by, I'm going to make this easier. So immediately let's divide it by 1,000. If we divide both sides by 1,000, these zeros go away, right? It's still 0 over here. Now we could easily divide both sides by 25. Let's do that. If we divide both sides by 25, we'll have 4x over x squared plus 36 minus 3 is equal to 0. Okay, I like doing that first because if I'm doing a sign chart, I want to simplify this so that I have something simpler to plug into, right? Does that make sense? Now let's go ahead and solve this for x. So 4x over square root x squared plus 36 is equal to 3, right? So 4x is equal to 3 square root x squared plus 36. And right here, I'm going to square both sides. So square both sides. 16x squared is equal to 9 times x squared plus 36, right? So 16x squared is equal to 9x squared plus 9 times 36. I'm just going to leave it like that. Subtract 9x squared from both sides. 7x squared is equal to 9 times 36. Divide both sides by 7. Square root both sides. That's why I didn't multiply the 9 times 36, by the way. 3 times 6 over square root of 7. Okay? All right, so now we're looking at a sign chart. Because again, we did not know what the graph of this C prime looked like, right? So do a sign chart, see what's happening for C prime. We would like it to go from negative to positive because remember we're trying to minimize the cost. So let's put in something to the left. And again, I'm going to go to this because that's why I did the simplifying that 100,000 and 75,000 to get to here. Okay, something to the left, something nice to the left. How about 0? That's a nice number to the left. If we put 0, we'll have 0 minus 3. That is negative. Now something to the right. Maybe a billion. That's to the right. Something to the right, we're going to have something close to 4, because I see a square root of x squared down here, and that's going to be close to x. Reduces with that x, so something close to 4. Anyway, it's going to be positive. That's what we wanted, because we needed for the cost to go negative to positive, right? So we do have a min. What were we trying to do? We're trying to find how far from point A should point P be located. We found how far. So locate point P, 18 over square root of 7 miles from point A, that phone. Sorry about that. The phone is right next to me. Okay. All right. That's an 18, not a 68. Okay. And that's it. All right. So I think that these are interesting problems to do. It makes you think, and that's a good thing. It's good to have to think once in a while. All right. You guys try some on your own now. And ask me what questions that you have.